Hello, myself Dr. Jadav, DKV Arts and Science College, Jamnagar. In our previous video, we understood about two laws, Lambert Law and B.Sc Law. Before proceeding, let's know about the formulators. The two formulators, one is Lambert and second is Beer. Johann Heinrich Lambert was a Swiss mathematician, physicist, a philosopher, and has command over astronomy and map projection. While August Beer was a German physicist, he was a chemist and a mathematician also. Lambert and Beer gave different laws. Lambert gave the law in 1760 and Beer gave the law after about 90 years, 1852. What does Lambert law suggest? When a beam of monochromatic light passes through a homogeneous medium, the decrease in intensity of light is directly proportional to the thickness of the medium. So, Lambert law is basically based on thickness of the absorbing medium. Similar law was given by Beer, which says that when a beam of monochromatic light passes through a homogeneous and transparent medium, while keeping the thickness of the absorbing solution or absorbing medium constant, there is decrease in intensity of light with increase in concentration. That means Beer discussed the law based on concentration of the absorbing medium. So, Lambert-Beer's law is a combination of Lambert's law and Beer's law. As I said, Lambert discussed based on thickness, while concentration was the factor which was given by Beer's law. The mathematical equation is when the beam of monochromatic light passes through a homogeneous medium, the decrease, this is minus that, the decrease in intensity of light is directly proportional to the thickness of the medium, whereas Beer's law says that decrease in intensity of light is directly proportional to the concentration of the medium, keeping the thickness constant. So, Lambert-Beer law is a combination of Lambert's law and Beer's law. That means combining this both equation, IT is equal to I0 e raised to minus K1 and K2 Tc. So, K1 and K2 P and C. So, Lambert's-Beer's law is the combination of thickness and concentration. Mathematical expression. Now, K1 and K2 are replaced by another constant, that is capital K. Remaining everything is same. Now, taking I0 here gives this equation. Now, you have to formulate in the reverse manner to give a simple mathematical formula. Removal of E. How we can remove? By applying natural log. So, natural log, if we apply natural log on both the sides, so in equation 2, it will give natural log of E raised to minus KCT, which is equal to minus KCT natural log of E. Natural log of E is nothing but is equal to 1. So, that is equal to minus KT. So, this is how minus KCT came. The fourth form is removing this minus sign. That means we can remove this minus sign by simply inverting this. So, that is what here it is done. By inverting this, minus sign is removed. Simplifying this equation, this gives this log. That means removal of natural log, I am applying log. To apply log, natural log is converted to log, we have to multiply by 2.303. So, that's what it is done here. This side it is multiplied by 2.303 and this is then shifted here. So, this is basically the mathematical form of Lambert-Beer law. This law or this mathematical form is simplified, but before proceeding, let's go through some important terms. There are three important terms transmittance, that is denoted by capital D, optical density and absorbance, OD, or it is denoted by A, both are same, and Xi, that is absorptivity and molar absorptivity. What is transmittance? Transmittance is nothing but a ratio of transmitted light and intensity light. So IT, transmitted light, and I0, ratio of transmitted light and incident light, is nothing but a transmittance, which is denoted by capital T. Optical density and absorbance or absorbance, it is nothing but log of ratio of intensity of incident light, that is I0, and intensity of transmitted light, that is IT. It is also known as log of inverse of transmittance. So optical density or absorbance is nothing but log of ratio of incident light and transmitted light, I0 by IT. Now, as we know, T is equal to IT by I0. T is equal to IT by I0, that is transmittance, based on the definition. So replacing this IT by I0 in this equation, that is OD or optical density is equal to A is equal to log of I0 by IT is minus log of T. Now log of I0 by IT is equal to log of 1 by T, because log of 1 by T. Now IT by I0 is equal to T, that means I0 by IT is equal to 1 by T. This is how 1 by T came, and simplifying this is T raised to minus 1. This can be simplified is equal to as minus log of T. This is how this term came, minus log of T. Now considering these equations in Lamberts law, which states that log of I0 by IT is equal to K by 2.303 PC. Log of I0 by IT is equal to Xi, which is nothing but K into K divided by 2.303. This is again a constant that is known as absorptivity. So this is equal to a chi, which is also sometimes known as capital E or small e. Now what is log of I0 by IT? As we all know, log of I0 by IT is nothing but minus log of T. Previous slide we showed that, and that is nothing but absorbance. Thus log of I0 by IT is minus log of T equal to A equal to this term. That is why A is equal to, this is also the simplified form or simplified mathematical form of Lamberts law. Now when in this equation, if we consider concentration in mole per liter and thickness of the medium L centimeter, A is directly equal to the absorptivity. This absorptivity is thus known as molar absorptivity or molar absorptivity coefficient. So along with this, Lamberts law can also be written as A is equal to capital ECT or small ECT or psi EC. So these are all mathematical or simplified form of Lamberts law. Thank you so much.